Ladies and gentlemen, my name is Mr. Jackson, and in this video, we're going to talk about how do you find the equation of a line given slope already in one order pair. And I'm going to show you two different methods to do that. One being plugging into point slope form, or you could do the same thing but in slope intercept form. So without further ado, let's get into the lesson.
Why do I have to stay here on the ground? It's overrated. The cityscape escapes you with a sound. It's delineated.
Now, for finding the equation of a line given slope in one order pair, first you need to understand, well, what even is slope and what does this order pair have to do with anything? So for number one, we have m equals 2. Slope is always represented by the variable m, and since it's positive 2, that means your line that you're trying to find the equation of is going in the positive direction from left to right. And for slope, remember you talked about earlier, probably in a previous lesson, that is the rise over the run. So you are rising 2 and running to the right 1 in the positive direction. In that order pair, 3 comma 9 and number 1, is that line is running through that order pair, which is why they picked this order pair. There's more than just one order pair that the line's going through. This is one that we can utilize, though, to actually find the entire equation of a line. So with that being said, let's go ahead and find the actual equation of a line for number 1, given the slope of 2 in the order pair 3 comma 9. So the first method I'm going to show you is utilizing point slope form. This is definitely the most beneficial formula to utilize when you are given a slope in one point. It's literally called point slope form for a reason. So I'm going to write down the equation right below number 1. It is y minus y1 equals m x minus x1. So we obviously know what m is already, that's our slope, but we need to figure out, well, what is x1 and what is y1? Well, that's where your order pair comes into play. Remember, when you're graphing on the coordinate plane, the x coordinate is always the first number in your order pair, and the y coordinate's always second. And if you ever forget that, I always tell my students, alphabetical order, x is always before y. So our 3 is going to be x1, and our 9 is going to be y1. And now we're going to plug in all of our numbers into point slope form. So this y stays the exact same, minus y1, which is 9, so y1 is going to be replaced with that 9, equals m is positive 2. We have our parentheses, x minus 3, and then we close that parenthesis. And now that your numbers are plugged into point slope form, the next step that we want to do is let's simplify this equation as far as we possibly can go. That way we end up at the very end getting our equation of a line. So we first check to see, can you do anything in parentheses? Well, x and negative 3, those aren't like terms. You can't combine those at all. So then I see there's a number on the outside of parentheses that we can utilize distributive property for. So we are going to distribute that 2 to every term that's on the inside of parentheses. So we have 2 times x, and we have 2 times a negative 3. That y minus 9 we're not going to do anything with right now, so I'm simply just going to bring this down. So we have y minus 9 equals 2 times x is just 2x. A lot of students overthink that part. Number times a variable, you literally just put them together. So 2x. And then 2 times negative 3 is going to be negative 6 or minus 6. And now from here, to get our actual equation of a line, you need to get y by itself now. And the only thing that's stopping it is there's a subtraction of 9 directly behind it. Well, how do you get rid of subtracting by 9? You do the inverse or the opposite of subtraction, which is addition. So we're going to go ahead and add 9 below that. But whatever you do to one side of the equation, you have to do the other. So we are going to add 9 over here as well. Negative 9 and positive 9, those are opposites, so those cancel. So now we're left with y by itself. So we have y equals 2x wasn't touched. And then we have negative 6 plus 9 that gives us a positive 3. And now we end up getting our final equation of a line as y equals 2x plus 3. So if you were to graph this, this line would be running through positive 3, which this number right here represents your b or your y-intercept. That line is running through positive 3 on the y-axis. And then we know that 2 is representing our steepness or our slope, meaning that your rise would be 2 and your run would be 1 in the positive direction. So now I want to show you the other method, which is slope-intercept form, where we take our slope in our order pair and still plug it into slope-intercept form, but we first have to solve for b or our y-intercept because we don't know that. Then we're going to go back and actually plug it into slope-intercept form to get our final equation of a line. So you're going to notice that point slope form actually gets you to the final equation of a line right off the bat, whereas slope-intercept form, you first have to find your y-intercept, then plug it back into the equation. So it's an extra step. So slope-intercept form is y equals mx plus b. So we have y equals mx plus b. We know that our order pair, the 3 is still the x coordinate and 9 is the y coordinate. You're going to notice that I'm not labeling it x1, y1 because that's not in slope-intercept form equation. We just have an x and a y. So we're still going to do the same thing, plug in all of our values that we know. So y was 9 equals m is 2 and x is 3. But I see students do this a lot where they simply just plug the 3 in directly behind the 2 and make it the number 23. M and x are being multiplied together. So this should actually be 2 times 3, but 3 being in parentheses here, so you don't accidentally make it the number 23. And then we're going to bring down that plus b, and you're going to notice we don't have a number to plug in for b, which we're solving for our y-intercept then. So b represents your y-intercept, or where that line is cutting through the y-axis. So we have to find that first. So let's go ahead and do our multiplying here. We just want to simplify this equation down. So we have 9 equals 2 times 3 is 6. We bring down that plus b. We need to get b by itself, so we're going to subtract 6 here, and that means we have to do the same thing on the other side. 9 minus 6 is going to give us 3 equals, the 6's are going to cancel, and we're left with 3 is equal to b. Now we need to go back to the original equation, which is y equals mx plus b. So we have y equals, our m was 2. We leave the x and y alone, and then we tack on that plus 3 at the very end, and now we have our equation of a line. Notice how we got the same exact thing as we did with point slope form, but we didn't actually have to go back and re-plug it in to get the equation of a line. So again, you can pick either method. I think point slope form is a lot easier with a little bit less work, but again, if your teacher asks you to do slope intercept form, well, you're going to have to solve for b, then plug it back into slope intercept form. So let's go ahead now and tackle number 2 using both methods. Let me get rid of all this and just rewrite the final answer. We have y equals 2x plus 3. And now for number 2, we have m equals negative 3, and then our order pair is negative 2, 4. So this is going to be labeled x1, y1 because I'm starting with point slope form. Let's plug in our values. We have y minus y1, which is 4, equals m is negative 3, parenthesis x minus x1, which is negative 2. And now we want to simplify as much as we can to get y by itself. But you're going to notice that what's inside parentheses looks a little odd this time. You're subtracting a negative, and if you're ever subtracting a negative, it actually turns to an addition problem. So subtracting a negative, this turns to adding inside the parentheses. So I'm just going to rewrite this. Y minus 4 equals negative 3, parenthesis x plus 2. And now we want to utilize distributive property because x plus 2 can't be combined together. So negative 3 times x, negative 3 times a positive 2. Y minus 4 we just bring down equals negative 3 times x is negative 3x. Negative 3 times 2 is going to be negative 6 or minus 6. And then we just need to get y by itself, and then we have our equation of a line. So get rid of subtracting by 4 by adding 4 to both sides. Negative 4 and positive 4, those are inverses or opposites, and we end up getting y equals negative 3x, and then negative 6 plus 4 is negative 2 or minus 2. So our equation of a line in slope-intercept form is y equals negative 3x minus 2. So let's make sure that we still get the same thing back using slope-intercept form. So we'll label this x and label this y. Let's plug in our values into slope-intercept form. So y is 4 equals m, which is negative 3. Make sure that x goes in parentheses, and then we have to tack on that plus b because we have to solve for our y-intercept first and then plug it back in. So let's do our multiplying. So negative 3 times negative 2 is a positive 6. We bring down that plus b. Let's subtract 6 to get b by itself. So 6 minus 6, that goes away. 4 minus 6 is negative 2 is equal to b. Then we go back to slope-intercept form, and it should be y equals, our m was negative 3, x is there, and then we tack on that minus 2 at the end for the same equation that we got in point slope form. So we have y equals negative 3x minus 2 as our final equation of a line, which is slope-intercept form. And then again, if you were to graph this, this line is running through the y-axis at negative 2, which is your b or your y-intercept, but this actually has a negative slope. So you are going to be rising 3, but going to the left 1 instead in the negative direction. So let's go ahead and jump down to number 3. We have a slope of negative 1/4, and then our order pair, this will be x1, y1, and let's plug it into point slope form. So we have y minus y1, which is negative 1, equals m is negative 1/4, parenthesis x minus negative 6. And you're going to notice here that we are going to have to change subtracting a negative to addition in both spots. So this will be y plus 1, and this will be x plus 6. So let's go ahead and rewrite everything. Y plus 1 equals negative 1/4 x plus 6. Can't combine what's in parentheses, so let's use distributive property here. So we have y plus 1, that's staying the same, equals negative 1/4 x. Well, that's just negative 1/4 x. And then negative 1/4 times 6. This is where a lot of students, all of a sudden, just because there's a fraction, life's over. Well, first, 6 isn't a fraction, but how can you make 6 into a fraction so you're actually multiplying two fractions together? Well, 6 divided by 1 gives you 6 back. So all we have to do, I'll just do this math on the side here. Negative 1/4 times, let's make 6 into a fraction by simply putting it over 1. Because what is 6 divided by 1? It still gives you 6 back as a final answer. So you can take any number, make it into an improper fraction without changing the value of it by simply putting it over 1. And now that we're multiplying fractions now, we can check to see, can you simplify anything to maybe make our math a little bit easier? So look at the numbers that are diagonal from each other. So I'm looking at 4 and 6 in specific right now. Can you divide either of those numbers by the same exact thing? Well, 1 obviously works, but is that going to change the number at all? Well, 6 divided by 1 is 6. 4 divided by 1 is 4. But both of those are divisible by 2. So 6 divided by 2, this is going to simplify down to 3. And 4 divided by 2 is going to simplify down to 2. Now it's going to make our multiplying a little bit easier. 1 and 1 on the other diagonal, you can't do anything with 1 and 1, so those are going to stay the same. So let's multiply our numerators together, or our top numbers together. Well, what is 1 times 3? Well, that's just going to be 3 up top. And then in our denominator, 2 times 1, that's going to be 2. And then we just want to make sure, is our improper fraction positive or negative? Well, you had a negative 1 times a positive 1. Well, a negative fraction times a positive is going to give you a negative result. So we're going to end up getting minus 3/2 for when you do negative 1/4 times 6. So we're just going to tack on a minus 3 over 2 here. And let's go ahead and get rid of all that just so we have a little bit of space. Now let's get y by itself. It's currently being added by 1, so we need to subtract 1 on both sides. 1 minus 1, that goes away. And then we're in a predicament again that now you are subtracting an improper fraction minus something that's not a fraction. So let's go ahead and do that math on the side once again. We have negative 3/2 minus 1. Well, how can I make 1 into a fraction without changing the value of it? Now, the only difference is between adding and subtracting and multiplying and dividing is you cannot add or subtract fractions unless they have a common denominator. So how can I make 1 into a fraction with a denominator of 2 with it still equaling 1? Well, doesn't 2 divided by 2 still give you 1? So if I change this and make this into 2 over 2, isn't that still 1 just like I want? Doesn't change the value of it at all. We have common denominators, which means we can go ahead and actually subtract this. So when you are adding or subtracting, the denominator stays the exact same number, and all you do is take the numerators and subtract them. So we have negative 3 minus 2, and you're going to end up getting negative 5 over 2. So our final answer in slope-intercept form, getting our equation of a line, is going to be y equals negative 1/4 x, and then we just did negative 3/2 minus 1. You get negative 5 over 2. And you are going to see questions like this. That's why I wanted to throw these in here. The first two were kind of like, hey, let's throw a feeler out there to see if you understand it. Now you're actually getting into fractions, having to be able to multiply them, especially if you don't get a calculator. Also understanding your adding and subtracting fraction rules. So just be very, very careful when you see a fraction. Okay, it's not hard once you get used to it. So that's the final answer for number 3. But let's do the same exact thing in slope-intercept form to make sure we get the same thing back. So let's go ahead and erase all this. We'll label our order pair x and y. We'll plug it into slope-intercept form. So y is negative 1 equals negative 1/4 times negative 6 in parentheses. We tack on that plus b that we have to solve for first. And you're going to notice, once again, we're going to have to multiply negative 1/4 times negative 6. So I am going to do negative 1/4 times negative 6. To make this easier, we make it into an improper fraction without changing the value of it by putting it over 1. Check to see, can you simplify anything? And again, 6 and 4 are both divisible by 2. So that's 2, that's 3. Then we have 1 times 3, that is 3 up top. 2 times 1, that's 2. We have a negative times a negative. That turns to a positive. So now we have negative 1 equals positive 3 halves plus b. And then to get b by itself for that y-intercept, we need to subtract 3 over 2 on both sides. We'll get rid of all this work on the right side just so we can do the subtraction again. So now we have negative 1 minus 3 halves. We need to make 1 into a fraction that has a denominator of 2 so we can actually subtract these. So that's going to be 2 over 2 because we just did that. So this is negative 2 over 2. Our denominator stayed the exact same, and we have negative 2 minus 3. And we still end up getting that negative 5 halves back that we got in point slope form. So that's what b is. The only thing that we have to do is go plug it back into slope-intercept form to actually get our equation of a line. So that's going to be y equals, m was negative 1/4, x minus 5 halves, which is identical to what we got in point slope form. Again, point slope form getting you to the equation of a line right off the bat, where a slope intercept form, you solve for your y-intercept or your b first, then plug it back into slope intercept form to get your equation of a line. And now on to the very last one. So let's go ahead and write our equation down for number 3, getting us that space. So we have y equals negative 1/4 x minus 5 halves. Now for number 4, let's use point slope form. So we'll label this x1, y1. Let's plug it into point slope form. So y minus negative 5 equals 4/3 on the outside of parentheses, x minus 8. I see that we have subtracting a negative out front, so that's going to turn to addition. So let's go ahead and rewrite that. We get y plus 5 is equal to 4/3 x minus 8. You can't do x minus 8. Those aren't like terms, so we have to distribute that 4/3. Y plus 5 we leave alone. 4/3 times x, that's just 4/3 x. And then once again, we run across that scenario where you have a fraction multiplied by a number that is not a fraction. So we need to make 8 into a fraction. We simply just need to put it over 1 and make it an improper fraction. So let's go ahead and do that on the side here. So we have 4/3 times negative 8 over 1. We check diagonally, can you simplify anything? Well, 4 and 1, the largest number that they're both divisible by is 1, so that's not going to change anything. And same with 8 and 3. So we can't do anything besides multiply our numerators and our denominators together. So 4 times 8 is going to be 32. 3 times 1 is going to be 3, and we had a positive fraction times a negative fraction, making all of this negative. So this is going to be minus 32 over 3. And then the only thing that is now left is we need to get y by itself by subtracting 5 on both sides. So minus 5, those cancel. But once again, we have to deal with a fraction being subtracted by not a fraction. So this is going to be negative 32 over 3 minus 5. Well, how do we make 5 into a fraction that has a denominator of 3 with it still giving us the value of 5 back? And we can change it to 15 over 3 because what is 15 over 3? You still get 5 back regardless. So we're going to do minus 15/3. And now we can go ahead and subtract our numerators because, again, our denominator stays the same number. That's going to be negative 32 minus 15, which is going to give us negative 47 over 3. So our final answer in our equation of a line is y equals 4/3 x minus 47/3 for our equation of a line. Again, it can get this challenging. I just want, again, you to see every type of example possible that might be thrown your way. So let's go ahead and do it again, but in slope-intercept form. So let's get rid of all this. Let's label this x, this is y. Let's plug in our values. So that's going to be negative 5 equals m is 4/3, x is 8, and then we tack on that plus b that we have to solve for first. We have to do 4/3 times 8, so let's do that on the side. 4/3 times 8 over 1. And then we can't simplify anything diagonally. 4 times 8 is 32 all over 3. So now we have negative 5 equals 32 over 3 plus b. And now we need to get b all by itself. So let's go ahead and subtract 32 over 3 on both sides. So minus 32 over 3. So we now have negative 5 minus 32 over 3. This cancels on the right side. And then we need to make 5 into a fraction that has a denominator of 3, which again we know is 15 over 3. minus 32 over 3. We subtract our numerator, so negative 15 minus 32 is still going to give us that negative 47 over 3, which is what b is going to be equal to. So now let's go ahead and plug that into slope-intercept form. So that would be y equals, our m was 4/3 x, and that is going to be minus 47 over 3 for number 4. Again, the same thing that we got for point slope form without actually having to solve for b first, then plug it back in. So those are the 4 problems I wanted to show you. Now we're going to make our way over to the practice session where you try 4 problems out on your own to see if you can get the correct equation of a line. Now it's time for the practice session. So I encourage you to pause the video here, try out all 4 of these problems on your own and see if you can get the equation of a line for each one of them. And when you think you're ready to go, come back and play the video and see if you get all 4 of them correct. So I'm assuming at this point you've tried out all 4 and you're ready to go over the answers. Now to cut down on some time, the first half already took me 20 minutes for the lesson. I'm going to do point slope form for 2 of these problems and then slope intercept form for the other 2. So let's go ahead and jump into number 1 and see if you got the first one right. And we're going to utilize point slope form for this first one. So we have m equals 5, and then for our order pair, we have x1, y1. Let's plug it into point slope form. So we have y minus negative 10 equals 5 parenthesis x minus negative 2. We're subtracting a negative in both sections here, so this is going to turn to addition. This is also going to turn to addition. We now have y plus 10 equals 5 parenthesis x plus 2. We're going to distribute our 5, so now we have y plus 10 equals 5 times x is just 5x. 5 times 2 is plus 10. We need to get y by itself. It's currently being added by 10, so let's do the inverse and subtract 10 on both sides. 10 minus 10, those cancel. 10 minus 10, those also cancel. And for our final equation of a line, we get y is equal to 5x. You're going to notice that there's no number tacked on at the end behind the x. That means if you were to graph this line, it's actually running through the origin at 0, 0. So it's crossing perfectly on the y-axis at 0, meaning we don't need to have a number behind our x here for our equation of a line. So if you got y equals 5x, very, very nice job. Now let's go ahead and tackle number 2, and we are going to utilize slope-intercept form for this one. So let's go ahead and get rid of all this. This is y equals 5x. And then for number 2, we're just going to change gears and use slope-intercept form. So for our ordered pair, this will be x. This is y. Let's go ahead and plug it into slope-intercept form. That'll be 5 equals 3/4 for m, or our slope, times x, which is negative 2 in parentheses. And then we have that plus b that we're solving for, which is our y-intercept. So we need to get rid of the multiplying. That's going to be 3/4 times, we want to make negative 2 into an improper fraction by simply putting it over 1. Then we can check to see, can you simplify anything diagonally? And I see that 2 and 4 are both divisible by 2. So 2 divided by 2, that's going to give us 1 there. 4 divided by 2, that's going to give us 2. And now we can multiply our numerators together and our denominators together. So 3 times 1 up top is going to be 3. In our denominator, 2 times 1 is 2. And then we had a positive times a negative fraction giving us a negative result. So this is now 5 equals negative 3/2 plus b. And then the only thing that's left is we need to get b by itself. So to get rid of that negative 3/2, we need to add 3/2 to both sides. The 3/2 with b are going to cancel because those are inverses. And now we need to do 5 plus 3/2. Let's make 5 into a fraction that has 2 on the denominator. Again, you can't add or subtract fractions unless they have a common denominator. So to change 5 into a fraction that has 2 in the bottom, this will be 10 over 2, because what is 10 divided by 2? You still get 5 back. So our 2 stays the same in our denominator. We just need to add our numerators together. So 10 plus 3 is going to give us 13 over 2. So we have b equals 13/2. And then for slope-intercept form, all we have to do is plug in that 13/2 for b. So we're going to end up getting y equals 3/4 x, and then we tack on that plus 13/2 for number 2. So if you got that for number 2, very, very nice job. That's one of the challenging ones. And now let's go ahead and jump down to number 3. So let me get rid of all this. We had y equals 3/4 x plus 13/2. And then down to number 3, we're going to switch gears again to point slope form. So let's label this x1, y1, and then plug in our values into point slope form. So we have y minus negative 6 equals, our slope is negative 2/3, parenthesis x minus 6. I see subtracting a negative out front, so that's going to turn to addition. So let's go ahead and rewrite that. We get y plus 6 equals negative 2/3 x minus 6. We need to distribute that negative 2/3 to both terms. So y plus 6 we leave alone. Negative 2/3 times x is just negative 2/3 x. And then once again, we're going to have to multiply a fraction and make 6 into a fraction. So that's negative 2/3 times negative 6 over 1. Check to see, can you simplify anything diagonally? Well, 3 and 6 are both divisible by 3, so 3 divided by 3 is 1, 6 divided by 3 is 2. Multiply our numerators together, so 2 times 2 is 4, 1 times 1 is 1, and then we have a negative fraction times a negative fraction that turns to a positive, and 4 divided by 1 is just 4, so I'm just going to make this plus 4 here. And now we can go ahead and get y all by itself. So it's currently being added by 6. Let's go ahead and subtract 6 on both sides. These will cancel, and we get for our final answer y equals negative 2/3 x minus 2 for our final answer for our equation of a line for number 3. So if you are 3 for 3 right now, very, very nice job going into the final stretch here. So let's go ahead and get rid of this. We had y equals negative 2/3 x minus 2. And then finally for number 4, we're going to use slope-intercept form. So this is x, this is y. Let's go ahead and plug in here. We get 3 equals negative 6 times negative 5 plus b. Again, we're solving for our y-intercept or a b first and then plugging it back into slope-intercept form. So we get 3 equals negative 6 times negative 5 is a positive 30 plus b. We want to subtract 30 on both sides to get b by itself, so these will cancel. 3 minus 30 is negative 27 equals b. Now let's go ahead and write in slope-intercept form, which is our equation of our line. Y equals negative 6x minus 27 for our final answer for number 4. If you went 4 for 4, very, very nice job. I hope this video helped you out in finding the equation of line given a slope in one order pair. If it did, leave a like on the video, comment any other topics you want to see in the future, subscribe, turn on that bell for post notifications, and we'll see you in the next one with some more mathematics.